This is chapter 9, Systems and Matrices. So here what we're going to do, I'm going to give you a little taste of what exactly matrices are and how they're useful. You'll learn a lot about them if you end up taking linear algebra, which is Math 254. So, but this is going to be a little introduction on them. I'll do a little review on systems and then we'll jump right into matrices. So the first thing is that we've kind of have learned how to solve systems that look like this. 2x minus y equals 5, and then x plus 4y equals 7. So we know how to solve this. And we know that usually the way that we would solve problems like this is by two different methods. The first one is what we call substitution, and the other one is what we call elimination. So you can always just pick your poison. So the way that it kind of works, and I'm going to use elimination because that's going to go really well with when we do matrices, and then back substitution will come later. But basically the process is that you're going to start off by 2x minus y equals 5, and then your other equation, write it right below it. And what elimination basically does is that you want to eliminate one of the variables. Now, one of the things that you can do is that you can see that I can just multiply this y by a 4 and that would go away. So if I multiply this first equation by 4, you're going to get 8x minus 4y equals 20, and then your second one's going to stay the same, so x plus 4y equals 7. So you can see here that this will go away. You're left with 8x plus x, which gives me 9x, and then 20 plus 7 is going to give me 27. So then finally I just divide by 9, and x equals 3. So then you solve for your y by plugging into whichever you'd like. So I'm going to plug it into the second one for no apparent reason. So I'm going to plug in 3 in there. So plus 4y equals 7. So I'm going to minus the 3 over. So you're going to have 4y is equal to 4. And then we just divide by 4. And we get y equals 1. So basically the way that we write it as a point. So we say 3 comma 1 is going to be the solution to the system of equations. Okay. Substitution is very similar. I'm not going to do it here, but you just basically solve for one variable and plug it into the other one. We've learned how to do this in very basic algebra and maybe like in high school. So there's a couple things that you should know about problems that look like this. You have 3 different types of solutions. So the first one is that the system has exactly one solution, just how we did here. So here we had exactly one solution for this particular system. The second type is that a system has no solution. So basically you arrive at a contradiction, and usually what happens is that when you solve the problem, you end up getting something weird like 0 equals 1 or 3 equals 2, which makes absolutely no sense. So whenever you arrive at a contradiction that looks like that, that just usually means there's no solution. The third one is that the system has infinitely many solutions. And usually what you arrive at is an identity like 0 equals 0, 2 equals 2. That means you have an infinitely many solutions. So when you have one solution, we usually call this consistent. And we say that we kind of also call it independent. Okay, so let's just call it consistent and independent. If you have no solution, we call it inconsistent. So this guy will be inconsistent. And if we have infinitely many solutions, we call this dependent. So the way that we really write them is going to be very, very different. So for example, I already gave you the example of the first one, which is no one solution. If you kind of look at the first 2 equations, you can see that these are just linear equations. So basically, if I were to graph them, so let's say the graphs kind of look like this. You can see that their intersection is going to be the solution. So that's basically what you're doing. You're solving where exactly these guys are being equal. So at this point, it will be 3 comma 1. Okay, now when will you have no solution? Well, you're going to have no solution when they're never going to intersect. So if you have 2 equations and they're parallel, then you're going to have no solutions. If you have infinitely many solutions, usually what happens is that one graph is just a scalar multiple of another graph. So basically this guy is right on top of each other. That's when you have infinitely many solutions. So the way that we write them in this class, in no solution and infinitely many solutions, is the following way. So we'll do one where there's no solution. So let's say, for example, you had 8x minus 2y equals 5. Then negative 12x plus 3y equals 7. Then basically what you want to do, let's go ahead and show that there's actually no solution to this problem. So one way that you can do it is that we want to go ahead and eliminate one of these. So I think it'll be easier to just eliminate the y's. So notice that I can multiply this by a number. I can't multiply 2 to get a 3, but can you think of 2 and 3? What is the lowest number or the highest number? Yeah, what is the lowest number that these two can divide into? And that will be 6. So I can convert this negative 2 into a 6 by multiplying this entire thing by a 3. So you're going to have 24x minus 6y equals 15. And then you can see that in the second one, you can multiply this entire equation to turn this into a 6 by a 2. So this guy is going to be negative 24x plus 6y equals 14. And then you see that not only do the x's cancel out, but the y's also cancel out. So I have 0 equals this weird numbers, which is going to be 29. So 0 does not equal 29. That means you arrive at a contradiction. So there's no solution here. So you can write no solution, or you can also say that the system is inconsistent. So basically what this means is that these two are parallel lines. Okay, so that system is inconsistent. All right, so how about something that's dependent? Okay, or something that has infinitely many solutions. How would we write the solutions in that case? So if you have this particular equation or system of equations, we're going to do exactly the same thing. So let's go ahead and look at the x values. So it seems that in the x values, I can eliminate those by multiplying it by a factor that will give me 12. So the first one, I'm going to multiply it by a factor of 4. So that's going to give me 12x minus 24y equals 48. And in the second one, you can see that I can get the other guy by multiplying this by 3. But notice that if I multiply it by 3, I'm just going to get 12 again. And that's not going to cancel out. So instead, I'm going to multiply it by a negative 3. So I'm going to get negative 12x, then a positive 24y, and then 16 times 3 is going to give me negative 48. So as you can see here, everything is going to cancel out. So you get 0 equals 0. So that means there's infinitely many solutions. Many solutions. So you usually would write that these guys are dependent, so the system is dependent. However, we're going to take it a step further. So the way that we're going to write the solutions when it's infinitely many is the following way. So we're going to say x is going to be a random variable. So x is just going to be a variable x. Okay, so when we write it as a point, x comma y, x is just going to be any number that I want. I'm just going to write x. Now, what would y be? Well, let's look at one of the equations. So let me just, because these two are basically scalar multiples of each other, I can choose whichever I want. I'm going to choose this guy. So 3x minus 6y equals 12. So what I'm going to do is I'm going to solve for the y value. So minus 3x minus 3x. So negative 6y is equal to negative 3x plus 12. So I'm going to divide this by negative 6. So then y is equal to, this is going to give me 1/2 x, and this is going to give me negative 2, which means that y is equal to 1/2 x minus 2, and that's what we're going to write here, 1/2 x minus 2. This is how I want the solution. This is basically the same thing that we were doing with parametric equations. So basically what we're doing is we're parametrizing it. Okay, so it's kind of like instead of x equals x, we're letting x equal t, and then plugging t into one of them and solving for the y. So that's just another way that you can kind of do it. Here I just chose x to be the parameter. So this is how you would parameterize it. So this is the solution that I want. I don't want you to give me infinitely many solutions. I want you to parameterize it and give it to me like that. Okay? So not only do we have systems of two equations, so this is two different equations, we can also do systems of three equations. Okay, so now what you're doing is you have something that maybe looks like this. So now you have something that looks like x minus 2y minus z is equal to 1, negative x plus 3y plus 3z is equal to 4, 2x minus 3y plus z is equal to 10. Okay, so here what you really want to be able to do, now it gets a little more confusing because now you have three different things that you're working with. And again, this can also give you the three different types. It can give you one solution, multiple solutions, or no solutions. Now, to solve this, the process gets a little harder. And if you kind of want to see it in three-dimensional space, lines in three-dimensional space are actually called planes. So I'm going to try my best to draw a plane here. So a plane looks something like this. So it's kind of like a sheet. Okay, let me see this. The dots are going to be behind the page. So basically, if I was looking at a plane, this little sheet kind of is telling you that this is going to be the equation of the line. And what you kind of have is you have multiple planes. So you have another plane that maybe goes like this. So you have a plane that intersects it. Okay, I'm not drawing this right, but you kind of have to have a little perspective. So imagine that you have a piece of paper that's crossing this plane. So you have many different things. I'm not even going to draw it. I tend to draw it anymore. But the whole point is that we want to be able to like kind of solve for the x's and the z's. So I'm going to quickly do this. Just try to follow along, and then I'm going to show you a different way to do it. So the whole point of this is that you want to be able to get this as far as we can to try to eliminate the x's. So the way that we're going to do this, or the way that I like to do it, is that I like to use these middle numbers as the guides to kind of get rid of these numbers, to get rid of these guys. Okay, so I'm going to try to get rid of the ones in red. So the way that I'm going to do it, think about the equation. So let's say this is equation number 1, equation number 2, and equation number 3. So I'm going to use equation number 1, so this x, to eliminate the other two. So how am I going to do that? Well, one of the things that I can do is that I can add equation 1 and equation 2 together, because then this is going to go to 0. So your equation 2 is going to be equal to taking, I'm going to write it like this, not number 2. I'm going to write it as equation 2. It's going to be basically adding equation 1 and equation 2 together. That's basically what I'm doing. All right, so I'm going to add them together. So that means that because I'm changing just equation 2, equation 1 and equation 3 are going to stay the same. Okay, so those guys stay exactly the same. When I add equation 1 and equation 2, so this plus this, that's just going to give me a 0. Then I'm going to add negative 2y with 3y. That's going to give me a positive y. Then I'm going to add this negative z plus 3z. That's going to give me a positive 2z. And then I'm going to add this 1 and this 4. That's going to give me a 5. Okay, so that's basically what I'm doing. So I got rid of that value. Now what I want to do is get rid of this 2x. And the way that I'm going to do that, so this is equation number 3. So equation number 3. What am I going to do? Well, I can multiply this first one by 2, but I have to multiply it by a negative 2. So I'm going to take equation number 3, and I'm going to subtract it by twice equation number 1. Okay, so what is this going to give me now? So because I'm working with equation number 3, equation number 1, and equation number 2 are going to stay the same. And the only ones that I'm going to work with is equation number 3. Okay, so equation number 3. So I'm going to take equation 3 and subtract twice equation 1. That's going to give me 0. Okay, then I'm going to take negative 3y and add it to negative 2 times negative 2y. So it's going to give me negative 3 minus 2 times negative 2. That's going to give me a 1. Okay, so I'm going to get positive y. All right, and then I'm going to take this guy. This guy is equation number 3, which is going to be z, and I'm going to subtract twice of that guy. So it's going to be 1 minus 2 times negative 1. That's going to give me 3. It's going to be plus 3z. And then you're going to take this 10 and subtract 2 times 1. That's going to give me 10 minus 2. That's going to give me an 8. Okay, so all I'm just doing is just arithmetic. I'm not really doing anything else, anything complicated. All right, and now finally what I'm going to do is I'm going to get rid of this guy. So now I need to get rid, so I got rid of these two. Now I got to get rid of this one. So I'm going to get rid of this guy. And the way that I'm going to do that is that, okay, equation number 3, what I'm going to do is I'm going to take equation number 3 and I'm going to subtract, use this guy to eliminate. So I'm going to subtract equation number 3 to equation number 2. And I'm going to put the new one in equation number 3. So what I'm going to get is that equation 1 and equation 2 are going to stay the same. So x minus 2y minus z equals 1. 0 plus y plus 2z, these guys stay the same. And now I'm going to just subtract these guys. So it's going to be this minus this, that gives me 0. So that gives me 0. 0, 0 gives me 0. This and this gives me another 0. So equation number 3 minus equation number 2, that's going to give me a positive z. And then 8 minus 5 is going to give me a 3. Okay, cool. All right, so now what exactly did I do? Well, what I did is that now I have a new equation. So x minus 2y minus z equals 1. Let me erase these zeros. Then I'm going to have y plus 2z equals 5. And then I have z equals 3. So the whole process of this, what I ended up doing was that I made this zeros, and then I can now substitute it. So now z equals 3, we already know that that's the answer. Now I can plug that z equals 3 into the next one. So y plus 2 times 3 is equal to 5. Y plus 6 equals 5. So y equals negative 1 there. And now that I know x and z and y, now I can plug it into the next one, the last one. So x minus 2y, which is negative 1, minus z, which is 3, equals 1. So x plus 2 minus 3 equals 1. This is going to give me a negative 1. So then x is equal to 2. So my solution, the way that we write it is x, y, z, which is going to be 2, negative 1, and 3. Okay, so this is what we call kind of Gaussian elimination, and we're going to do it in a matrix form. So for right now, if you got it, that's great. If not, you can rewatch the video because it is a really weird process, especially when you're dealing with a lot of the different types of arithmetic. So we'll talk about matrices in the next video.